A very good morning, sir. I'm Faiza Sultana from 2nd CSE A section. The subject name is Operating Systems, and the code of the subject is 23 CSE 402. And my roll number is 234G1A0540. The topic of the operating systems which is assigned to me is methods for handling deadlocks. Introduction to deadlocks. Deadlocks occur in multi-threaded environment when two or more processes are unable to proceed because each is waiting for the other to release resources. They can severely impact system performance and lead to unresponsive applications. Understanding how to handle deadlocks is crucial for maintaining system efficiency and reliability. So, understanding deadlocks is very important to the one who is suffering with the problem of this, and this is very important to maintain the efficiency and the reliability. What is a deadlock? A deadlock is a specific condition in which two or more processes are blocked forever, waiting for each other. It often arises in resource allocation scenarios where multiple processes compete for limited resources. Identifying deadlocks involves recognizing the circular wait condition among the processes. Necessary condition for deadlocks. Four conditions must hold simultaneously for a deadlock to occur: mutual exclusion, hold and wait, no permutation, and circular wait. Mutual exclusion means that at least one resource must be held in a non shareable mode. Understanding these conditions helps in designing systems avoid deadlocks. So the four necessary conditions are written here as you can see. Mutual exclusion process claim exclusive control of the resource they require. Wait for process hold resource already allocated to them while waiting for the additional resources. No preemptation. Resources cannot be removed from the process, holding them until the process are used to completion. Circular wait. A circular wait chain of process exists in which each process hold one or more resources that are requested by the next process in chain. Deadlock prevention. Deadlock prevention aims to ensure that at least one of the necessary conditions cannot hold. These can be achieved eliminating conditions like a hold and wait by requiring process to request all need resources at once. Although effective prevention can lead to resource underutilization. Deadlock prevention necessary conditions for deadlock. Mutual exclusion, hold and wait, circular waiting, no preemptation. Ensure that at least one of the necessary conditions is false at all times. Deadlock avoidance. In deadlock avoidance, the system makes decision based on resource allocation to ensure that a deadlock state is never reached. The banker's algorithm is a popular method for deadlock avoidance requiring information about maximum resource needs in advance. While it can effectively prevent the deadlocks, it requires the careful management of the resource allocation. Deadlock detection. Deadlock detection involves checking the system periodically for deadlocks and taking corrective actions if they are found. A wait for graph can be used to represent resource allocation and detect cycles indicating deadlocks. This method allows for flexibility in resource allocation but may lead to temporary system efficiency. So, the deadlock detection is of two types: single inheritance and multi instance. A single instance wait for graph, multi instance safety algorithm. Deadlock recovery. Once a deadlock is detected, the system must recover from it to restore normal operation. Recovery strategies can include process termination, resource preemption, or rolling back processes to save states. Each strategy has its trade offs between performance and complexity and resource utilization. Process termination. One straightforward recovery method is to terminate one or more processes involved in the deadlock. This can be done based on various criteria such as priority or resource consumption. However, terminating process can also lead to loss of work and require additional mechanisms to save the progress. Resource preemptation. Resource preemptation involves forcibly taking resources away from the same process to resolve a deadlock. This can allow other while waiting for resources to be released. Implementing a preemptation can be complex and may require state saving mechanisms. Rolling back mechanism. A rollback mechanism allows processes to return to a previous safe state if a deadlock is detected. This approach can minimize data loss as process are restored to a point before the deadlock occurred. However, it requires maintaining historical data and can introduce more method overhead in managing state. Comparison of strategies. Different methods of handling deadlock have various impacts on resource utilizations and system performance. Prevention and avoidance can be proactive, while detection and recovery are reactive strategies. The choice of the method depends on the specific system requirements and the operational constraints. Deal with the deadlock problem in one of the three ways, that is, use a protocol to prevent or avoid deadlocks, ensuring in the system never enter a deadlock state, allow the system to enter a deadlock state, detect it and recover, ignore the problem altogether and pretend that the deadlocks never occur in the system. Deadlock handling in database. Databases are often implement the deadlock handling mechanisms to ensure data integrity during the concurrent transactions. Techniques like timeout and wait for graphs are commonly used in the database management systems. Um, Understanding this method is crucial for database administrators to ensure optimal performance. Operating